Welcome to episode 7 of our Design Patterns in Java series. Last time we covered the adapter pattern and learned how to make incompatible interfaces work together. Today we're going to learn how to add behavior to objects dynamically without altering their structure, using the Decorator pattern. This pattern is extremely useful when you want to enhance functionality in a flexible, reusable way, especially when dealing with components like UI widgets, stream processing, and even logging. It's also used quite a lot in React and React Native. What is the Decorator pattern? The Decorator pattern is a structural pattern that lets you dynamically add responsibilities to objects at runtime. It provides a flexible alternative to subclassing for extending functionality. The key idea is to wrap an object with another object that implements the same interface and adds new behavior before or after delegating calls to the original object. Some fun use cases are adding features to UI elements, borders, scroll bars, shadows, or whatever, enhancing streams in Java input-output or Java I/O, like the buffered input stream or the data input stream, decorating loggers with timestamping, coloring, or filtering, and wrapping services with cross-cutting concerns like caching or validation. The example we're going to use is text formatting with decorators. Let's say you have a basic text formatter. You want to be able to decorate it with behaviors like bold, italic, or even HTML formatting, and you want to combine them in any order. This example will demonstrate how decorators can wrap one another and modify behavior without altering the original object. Let's dive into the code, and for that I need to be small. Bam, we can go into our code. So first of all, we have defined an interface, which is text. And text just has a string function that renders stuff and returns a string. Beautiful, right? Okay, so we have plain text, and plain text implements the text interface. It has a string content variable, or field, or however you want to call it. And then we have a constructor, it gets passed in, and it just renders it by returning the content. Plain and simple. Then we can create an abstract decorator called text decorator. And that's this. The abstract decorator implements the same interface, text, and wraps another text object. This allows decorators to be used anywhere a text is expected, while giving them access to the inner object to modify behavior. See how it does that? It just says inner equals inner, and then we can go to our bold decorator. So we have a concrete decorator here called bold decorator. These decorators extend text decorator and override the render method to wrap the content in HTML style formatting. The real power comes from their ability to be stacked. Each decorator doesn't care whether it wraps a plain text or another decorator, it just modifies the output of the render method. We also have an italic one, and the italic one just, puts the Y's there for italic, the B is for bold, and that's all it does. You get text inner, you call super with the inner text, and you just render the inner text and you add whatever you want to add to it. This returns a new string using the old string. See what it does here? You use inner.render. So the stuff that's in the decorator above you, if I say it correctly, and then you wrap your stuff around it and return the combined result. So you have the text decorator, it has a text. Inner might be confusing, but just, stay with me. What you're doing here is setting a variable. So you just say, okay, the original text is this, right? The original text is text. Then you call super inner. So what you do is you call the text decorator. You set the inner one. This is also extending text decorator. So it has inner text, right? And then you just return whatever the render method is called. You return your inner and the stuff you want to add to it. It may be confusing if you see this right now. So let's just move to our main method to see it actually, do what it's supposed to do. So first we have a text, simple, and it creates a new plain text with hello world. Now we have a new one, a bold decorator, and we pass in plain text here. So the simple, we pass it in there. So we have plain text, it implements text, right? Simple. And then we have our bold decorator and we pass in simple. So it's this string, basically, sort of, getting passed into this one. And it calls super.inner. And it says, hey, I have a text of something that adheres to the text interface. See? It stores that. And then the bold decorator just uses that and wraps whatever it wants around that. And then you have bold text. And the same goes for italic. We pass in the bold one. So now it has hello world and the stuff that the bold decorator put in there, the B. And now we call the render on that. And it is italic and bold. So let's run it. So you see what it did? It was hello world first. Then you have the super, right? Whenever we call the render, it's just the bold and the other stuff. But then we pass the bold in there, right? And then we call the render method. And then it got set to hello world plus bold. And then it added its own italic stuff there. Wait, this one. So every time there's more functionality or more behavior added to the object. And that's how we come to this. So we started off with hello world, then it became hello world wrapped in bold, and then we passed in the bold to the italic decorator, which added the italic stuff, and now we have italic, bold, and plain text all combined in the same thing, whilst using the decorator pattern. So it might be a bit confusing, so be sure to dive through the code, code it yourself, and let's go through it one more time. We have a text interface. We have a text decorator, which implements the text interface. So that is text, right? And it stores an inner text. So the text decorator gets passed a text. Then we have plain text, which implements text. And then we have a bold decorator that gets passed in something that adheres to text, but it's also extending the text decorator. So what we're doing here with text decorator, we're saying, hey, I have the first plain text there. Then we add some stuff here whenever the render method is called. And then we do the same for the italic one. And then everything gets stacked on top of each other. And that's how it all works. So the benefits of this is actually that it promotes the open-closed principle. Classes are open for extension, closed for modification. It also enables runtime configuration of behavior through composition. It reduces inheritance hierarchies that try to cover every possible combination, and it supports flexible feature layering. Decorators can be added or removed without altering the underlying code. Downside is that it can lead to many small classes if overused. Stack depth can make debugging way harder, and it requires discipline to ensure decorators are used meaningfully. And some best practice: keep each decorator single purpose and avoid bloating them with unrelated logic. It is hell when decorators are way too big. Maintain clear naming for decorators to express their role. When stacking multiple decorators, ensure the order makes logical sense, and document which decorators can or should be used together. Now, for a quick recap, today we used the decorator pattern to enhance a text component with new formatting behaviors without modifying its source. Using composition and delegation, we showed how to layer decorators like bold decorator and italic decorator in a flexible way. In the next episode, we'll dive into the facade pattern, which simplifies complex subsystems into a clean, easy-to-use interface. Thanks for watching, and don't forget to like, subscribe, and stay tuned for the next episode. Have a great day and happy programming.